Hey students, welcome back. This is 6.2. This is Boyle's Law, so please write your header on your notes. All right. We are talking about empirical gas laws. We're going to spend a few days talking about the empirical gas laws. What it means to be empirical is we're talking about the simpler ones, all right? Because then they combine into what is called a combined gas law, but we'll get there in just a second. So, jumping into Boyle's Law, what it says is that pressure is inversely proportional to volume. Now, what that sounds like is it sounds like a really smart way to say something, and what does that mean? So, what does it mean? Does it mean that as pressure goes up, what will happen to our volume? If we increase the pressure, what will happen to the volume? Okay, what if we think about having a balloon, all right? And we want to increase the pressure on the balloon, so we squeeze it. What happens to the volume? You're right, the volume goes down. So they're inversely proportional. One goes up, one goes down is what that means. So we have actually a formula that we can use to do some calculations with Boyle's Law. And so let's kind of blow this up and go for the formula. So our formula is P1V1 equals P2 V2. So we're going to be changing pressures and volumes as we go through and seeing how they affect each other. Okay? So let's work an example. And so what we got? Okay. A sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947. What will the volume of the gas be at a pressure of 0.987 atmosphere if the temperature remains constant? So let's kind of go through and label what we've got here. So this first number is a volume. So I'm going to say V1 because that's the first volume I saw. Which means this next one, it says it's a pressure, right? So this is P1. What will the volume, we're looking for volume, so we're going to be looking for V2 at a pressure of 0.987 atmospheres. So this is going to be P2, all right, if the temperature remains constant. So what we're going to do there is kind of be ready to plug it in. I like to write out what I know on each side. So I've got P1, which is 0.947 ATM. I've got V1, which is 150 milliliters. I got P2, which is 0.987 atmospheres. And then I have V2, which is my question mark. So now we're ready to just plug it into our formula. And remember, our formula is P1 V1 equals P2 V2. All right, we've got P1, which is 0.947 times V2, 150, is equal to P2, 0.987, and then we've got V2, which is what we're looking for. So we need to isolate V2, and to do that, we're going to just divide each side by 0.987, just making sure we're all on the same page on how to do this. All right, so V2 is going to turn out to be 0.947 times 150, and then divided by 0.987. So we go ahead and calculate that again, 0.947 times 150 and divided by 0.987. And our answer, with two decimals, we're going to say 143.92. And our label on that, well, our volume was milliliters, so that's going to be the same there. So we're going to say ml, milliliters. Okay? There we go. Awesome. Let's roll on to the next one. Okay. This one says the pressure exerted on, let me get back to a new color here. The pressure exerted on a 240 milliliter sample of hydrogen gas at a constant temperature is increased from 0.42 atmospheres to 0.725 atmospheres. What will the final volume of the sample be? Okay, let's go through and break down. All right, the pressure exerted. Oh, look at this. This is a volume. We've got V1 because remember, volumes are measured in milliliters, right? Is increased from, here's a pressure, P1 to P2, we're looking for our final volume, or V2 as our question mark. So over here to the side, P1, we've got 0.428 atmospheres. V1 is our 240 milliliters. P2 is 0.724 atmospheres. And V2 is our question mark. So it's very similar to the last one in our setup. Repeating, we've got P1 V1 equals P2 V2. Plugging it in, 0.428 times 240 is equal to 0.724 times V2. Now again, we want to isolate and get our V2 by itself. So we're going to divide each side by 0.724 so it cancels on each side. All right. And V2 will be equal to 0.428 times 240 and then divided by 0.724. And we're ready to do our calculation. 0.428 times 240 divided by 0.724. And our answer, again, with 2 decimals, we should get 141.88, and our label is milliliters. Okay? Awesome. Let's see if we can try one where we have to find for a pressure. Okay? It says the volume of a movable piston is decreased from 15 liters to 4.5 liters. If the initial pressure was 1.0 atmospheres, what is the new pressure? All right, so let's go through and label up what we see there. All right, we've got 15 liters. That's a volume, so I'm going to say that's V1. This is V2 because it's liters. And our initial pressure, so this is going to be P1. We are looking for the new pressure, so we're going to call that P2. So let's write down what we know. We know we have 1.0 atmospheres. P2, sorry, I didn't mean to write that. We should be V1, trying to keep it the same. V1, we have 15 liters. P2 is our question mark this time, and V2 is 4.5 liters. Okay, now we're ready to calculate P1 V1 equals P2 V2. So P1, we've got 1.0 times 15 liters is equal to P2 this time times 4.5. Again, we're going to try to isolate our P2. We're going to divide by 4.5 on each side. Boop, boop. And so to find our answer, 1 times 15, obviously 15, and then divided by 4.5. And our new pressure, P2, is 3.33. Does that make sense? Did it go up because our volume went down? Yes, it did. Our volume went down by almost, what was that, 2/3? So our pressure went up by almost like 2/3. Okay, awesome. See you next time.